Hello. Now we are going to look at how to draw stem and leaf plots and how we can use them. So if we have 10 students and we ask them to estimate the length of a piece of string in centimeters, this is the answers that we get back. So we can see we have 10 students, and the first one said that the string might be 21 centimeters long, another one said that it could be 32 centimeters long, and so on. If we want to represent this on a stem and leaf plot, the way a stem and leaf plot works is it groups the data together, usually in groups of tens. So here, 21 centimeters, we'd have 2 in the tens and 1 in the units. So the 2 here would be in the stem, it would be the tens, and then the unit would be what's on the leaf. Here we have a two-sided or a double-sided stem and leaf. And we have a stem of 12, and from the key at the bottom we can see that that means 120. So this is 120 and then 6 on the units. What's important is that it's always a single digit that goes out on the leaves. So the stem can have several digits in it if it needs to, but the leaves will always have a single digit. So the final digit is the leaf, and then the stem is going to be filled with whatever we need it to be, usually tens or 100s or something like that, but it can be anything. And our key at the bottom is going to tell us what our stem means, because it could mean anything if we don't specify. So let's get into this. When we want to draw our stem and leaf, we're always going to draw a disorganized stem and leaf first, and then draw an organized stem and leaf. The reason is, in principle, we could write things from smallest to biggest when they're in a group like this. But if we have to draw a stem and leaf anyway, we're much less likely to make a mistake if we break it up into our groups of 10 first, into our disorganized stem and leaf, and then organize the leaves afterwards. So that's what we're always going to do if we need to draw a stem and leaf from a disorganized data set. We'll draw a disorganized one first, or a disordered one first, or an unordered one. So we'll do an unordered one first. And what we need to do is decide what's in the stem. In this case, this is a single-sided stem and leaf, so I just need a single line. But if you wish to draw a second line, that's totally fine. And just for similarity to the others, I can draw it in. You don't need that line technically for a single stem and leaf. I need to look at what needs to go in here. So I can see that I have 10s, 20s, and 30s. I don't have anything else. So I'm going to put 1 for 10s, 2 for 20s, and 3 for 30s. And what I'm going to do is start filling this in, making sure that I put a single number in each box on my grid. I need to keep these a very consistent distance apart. Just like any of our graphs that we draw, neatness and consistency are very important to getting the marks and being able to use them. So 21 would be 2 on the tens and 1 unit. There's no comma that we tend to put in between these. It just tends to be a consistent spacing is how we indicate that there's more than one leaf. And also we know that each number will only be 1 digit. Each leaf is only 1 digit. So 32 is 3 tens and 2 units. 17 is 1 10 and 7. 21, 24, 27, 21 again, 10, 27, and 28. So now we have our disordered stem and leaf. We should still really draw in a key. So that's what we're going to do. A key, just like on a map, tells us what we're talking about, what the different symbols and structure means. So in this stem and leaf, if we see something like 1 in the stem and 7 in the leaves, that means we're talking about 17 centimeters. That's what that means. If we see that there, 1 in the stem, 7 in the units, that means 17 centimeters, the guessed length. or the estimated length. Now we've done an unordered one, we're going to do an ordered stem and leaf. Follows exactly the same pattern. Draw our line down, keep everything as neat as we can. We can draw a second line, it doesn't do any harm. And 1, 2, and 3. There's no significance to the line continuing on down past where it needs to. It doesn't do any harm, it doesn't do any good. Now, what we want to do for the ordered one is put everything from smallest to biggest. So our leaves at the moment, 7 and then 0 doesn't make very much sense for smallest to biggest. So 0 and then 7 is much better. And then we have 3 ones. And then 4. And then 7, 7, and 8. And now we have our ordered information. We start with the smallest number being 10, and we can then go up to the largest number, which is 32, and everything is listed from smallest to biggest, as we often want it for our data when we're doing our interpretation of the data sets that we're given. So now we have our ordered stem and leaf. What's the range of our data set? Well, this is very easy. When we have our ordered stem and leaf, we know we're going from 32 is our biggest, 10 is our smallest. So the range is the highest minus the lowest. Change color. So highest minus lowest is going to be 32 minus 17. So our range is 15 centimeters. What's the mode? The mode is the most frequently seen number, the most popular number. And that is 21. So I simply looked at, I have two 27s, but I have three 21s. So 21 is the modal number. 21 centimeters is the most frequently seen estimate of the length of the piece of string. What's the median? So the median is going to be the middle number when we have ordered from smallest to biggest. The stem and leaf has done that for us. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. That's an even number. So we need to be careful now with our median. We go 1, 2, 3, 4, 5. Well, between 5 and 6 is going to be halfway between our data set. So there's no number that's actually exactly halfway through our data set. But halfway between 21 and 24 would effectively be the middle of our data set. So our median is going to be the average of 21 and 24. Is going to be the mean of 21 and 24, our two middle numbers. And we get 22.5 centimeters was our median guess. What is the mean? The mean is add up all of the numbers and divide by the number of numbers. So we add up all of our numbers. In this case, it's getting a little bit large to write it out explicitly, but we can do so. So our mean is our x bar, and we write out what it means. And we get, when we write out all of these, it gets a little bit finicky, even with 10 of them, to write them all out. So if we get a large data set like we have for our other questions, we don't need to worry about it. But anytime we have space, we should write out explicitly what we're doing, so that if we make a mistake, we can still get marks for our correct method. And it also sticks the method better in our memory. So we get a mean of 22.8 centimeters. The string is actually 25 centimeters long. What percentage estimated too high? So let's look at our ordered stem and leaf, and we have 1, 2, 3, 4 people who estimated too high out of a total of 10. That'd be 4 out of 10. To turn that into a percentage, we could turn it into a decimal and multiply above and below by 100, but in a case like this where it's an easy thing to convert the denominator to 100, that's 40 out of 100 is 40%. Now, with our back-to-back stem and leaves, they work exactly the same way. So here we're dealing with the heights of students in first year and in second year. The stem works as you might expect. So we have 120 centimeters, 130 centimeters, 140 centimeters, 150 centimeters, 160 centimeters. So we have two numbers in the stem, but we know that we always only have one digit out on the leaves. The leaves read from left to right, regardless of which side of the stem you are on. And we needed a separate key on both sides to make sure that we are very clear on what we mean. So 0 and then our stem 1, 2 would mean 120 centimeters, and 12 in our stem, and 6 would mean 126 centimeters on the right. So that's how we read our pieces. And one thing to point out here is we have an outlier. There was one student in first year who was 160 centimeters tall in first year, which was significantly taller than everybody else in first year. So we have an outlier there, which I didn't ask a question for, but there's an outlier in our data set, which they'd often ask for. Part 1, first year mean height. We just do what we did here, but you would not write it. Well, you could just about write it out, but you can put that on your calculators and you will get that the mean ends up being 134.53 centimeters. Add up all your numbers and divide by your number of numbers. Same for second year. So the mean for second year ends up being 144.6 centimeters. And then our final question, Joe stayed at 140 centimeters for both years. How did his position in the group change? Well, in first year, Joe's height was above average. So in first year, they were above average, or above the mean. But in second year, as they didn't change and a lot of people got taller with their growth spurts, they ended up below average. That's a very basic comparison between our two data sets. And if we had more about the range and the median and the mode, then we would be able to make even more comment. But at a very basic level, they went from being slightly above average height to being slightly below average height. Now, here we have the results of two tests, one in fractions, the other in algebra, and we're asked some questions about it. So what was the median result for the fractions test? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people taking our fractions test. So that means that if we need to go halfway through our data set, is going to be between 5 and 6. So 1, 2, 3, 4, 5 is here, which is a little bit awkward. So that's between 58 and the next number would be 67. So we're looking for between 58 and 67. So the average or the mean of our two middle values, because there is no middle number, and we get 62.5. And in this case, we can see from our key that we're talking about percentages, so that means it's 62.5%. Part 2, the algebra median. So what was the median for our algebra? Again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people again. So 1, 2, 3, 4, 5. So we're looking for the average of 61 and 63, which is 62. 61 plus 63 all over 2, because we have an even number of people, and we have 62% was our average, or our was our median for the algebra test. Part 3, the algebra mean. When you add up all of your numbers and divide by the when you add up all your numbers and divide by the number of numbers, you get 67.5%. And the algebra mean without the outlier. So where's our outlier? We have it right here. Someone had a very bad day and they got 23%. So if we exclude that person, we have 9 people left. So we add all of them up. So the mean becomes 72.4%. So a very big difference when we exclude the outlier. And the algebra median without the outlier, well, when we do that, we get that it's 63%, and we can see the mean is heavily affected by the outlier and the median almost not at all. And that's what we need for now.